with. You've got your handout in front of you. Last week we spent a few days dealing with the sine law. Please, I need to know this. Can you put your hand up if you were not here on Friday? Okay, so you'll want to pay careful attention to the second part of what I'm going to review here. The first part you should pay attention to anyway, but the second part is what you missed if you weren't here Friday. Well, let's just take this from the top. We have this tool called the sine law, or the law of sines. And really what it says is any triangle in the universe, it doesn't matter. It could be a right triangle. It could be a right isosceles triangle, but it doesn't have to be. It might be a triangle with an obtuse angle, but it doesn't have to be. It might be a triangle with 3 acute angles and all of the sides different, but it doesn't have to be. Any triangle in the universe, the sine law can be used to describe what's going on. I'm going to label this as x, y, and z. The side across from angle x is called x. The side across from angle z is called z. The side across from angle y is called y. What does the sine law say? The sine law says if you take the length of a side of a triangle and divide by the sine of the angle that's across from it, you'll get the same thing no matter which pair you choose for that triangle. And it could be a different triangle. And if it were a different triangle, this ratio would have a different value. Right? I'm not saying x over sine x is equal to y over sine y in a different triangle. I'm saying x over sine x in this triangle is equal to y over sine y in this triangle, which is equal to z over sine z in this triangle. Go to a different triangle, you'll have different angles and different sides, but that will still be a true statement. And what we did the day before our last class, which would have been Thursday, what we did was we solved problems where you had, for example, a triangle, doesn't matter, I'll put some numbers in here. Let's say that this is 20. This is 82 degrees. This is the side that we want to find, and that's 58 degrees. The day before our last day of classes, so last day of classes we were together was Friday. I'm talking about Thursday. And in fact, I believe on Wednesday we did this as well. We found that side using the sine law. I mean, not this side in this triangle, but we did find sides using triangles. The thing I want to stress to you is that this only works if you know a pair, right? This should be familiar to everybody. You have to know an angle-side pair. And if you want to find this side, then you need to know this angle, right? You need to know a full angle-side pair, and you need to know half of an angle-side pair to find the other missing piece. Carter, how are we going to find this angle?
We have 82, and you take the answer and you subtract it from 180.
Excellent. It's exactly what we do. 82 plus 58 will give us, I think, 140 degrees.
Yeah.
And we take 140 degrees away from 180 because all the angles have to add up to 180, which gives me 40 degrees here. And my triangle isn't drawn perfectly to scale. I mean, I can easily show you that it's not. Wow, 41 degrees, that's not bad. It's actually 41. This is 82.9. I actually came pretty close, didn't I? But anyway, now we can solve the problem. I can go x over sine 40 degrees equals 20 over sine 82 degrees. And this should be like stealing candy from a baby. No problem at all. I would like everybody to solve that equation for me for x. think sooner or later we have to graduate beyond having to draw the fish every time. Some of you like to draw the fish. That's fine. If you want to do that, go ahead and do that. I'm not going to. I'm going to cross multiply. I have to take sine of 40 times 20 divided by sine of 82. Don't forget to always close the brackets on any angle that you're taking a sine or a cosine or a tangent of. Times 20, and then divided by sine of 82. And that means that x is approximately 13. Capiche? All right, no problem there. That's what we did before Friday. That dot above the equal sign that I just put just means about. Okay? What we did Friday is we used the sine law to solve the following kind of situation. I'll give you a different example. .30-degree angle here, 22 centimeters here. .31 centimeters here. Question is, what's this angle? So, how do we go about doing that? Well, do you have a pair? Do we have a pair here in this triangle? We do, which means, and that's going to be when we learn a little bit later today about the cosine law, which is different, that's going to be your test. If you know a pair, you're off and running with the sine law. And the pair we know is this angle and this side. Do we know half of the pair that has the angle we're trying to find in it? Which means look at the angle we're trying to find. Do we know the side that goes with it? Well, we don't. And this is different than the previous one where we could figure out the missing half by just adding the angles together and saying they have to add up to 180. This is different. This means you cannot find angle A at all right now. But what you can do is find this angle instead. And once you know that angle, then you can find the missing angle. So what do we do here? Well, we have a green pair. I'm just going to change the color that I drew this in. We have a green pair, the 22 centimeters and the 30 degrees. We have a bluish pair, angle B, which we don't know, and 31 centimeters, which we do. And if you were not here Friday, this is the new thing, okay? If you were here Friday, you should realize that what I'm about to write is probably not what you would write. Okay? You would normally write 31 over sine of angle B equals 22 over sine of 30 degrees. Does that make sense? What did I tell you guys on Friday, though, about that? What did I suggest to do? LJ, I just saw you. Flip it over. When you write it down, just write it down upside down because it's easier to get the right answer. It's harder to make a mistake if your unknown is on the top, not the bottom. So since we're trying to find an angle here, you probably don't even write that. What you would do is say sine of B over 31 equals sine of 30 over 22. And then cross multiply. So sine of B will be 31 times sine of 30 divided by 22. I would like you to calculate what sine of B is for me, please. That's what I get. Yeah? Yes?
I don't know how to use this calculator
Because it's that calculator?
Not the one I've been using.
What kind have you been using? Like the kind that I have on the screen? And that's fine. It's good to use the same tool all the time, right?
Thanks.
You're welcome. I didn't check to see if it's in degrees, though, so make sure it's in degrees. But are we okay with that? We're getting that? So that is not the answer. Now, if you're not getting that, you may not be in degree mode. Just hit, if you have this kind of calculator, hit mode and make sure it's highlighted on degrees. And if it is, I'll go through that calculation one more time. I'm going to quit out of here. You have to take 31 multiplied by the sine of 30, and then close the brackets on the 30 and divide by 22. Okay, so you getting that? Let me just take a look. Okay, so we got to go. Try it now. I'll bet you it'll work now. You're good though, eh? Okay. That sine of b equals 0.704545. Well, that's weird. Just keeps going. 0.7045 with the 4, 5 repeating. That's not the angle. Leah, do you know what we have to do to get the angle? Don't remember? But we've done this before with sine and cosine and tangent. When you're trying to find the angle, do you remember?
You gotta subtract holding to find number for B.
Right, but this isn't even angle B yet.
You gotta do second sine.
Second sine, right? Whenever you're trying to find the angle, you got to go inverse sine or second sine, or there's a lot of different ways to describe it. So on our calculator, what we have to do is go second sine of that number, and we get 45 degrees. And that means that angle B is 45 degrees. Now we can worry about finding angle A. And that's going to be found by taking 30 plus 45 and taking the result away from 180, 105. And I did a really poor job of drawing my triangle this time. 105? Yeah. So this is 105 degrees. I mean, clearly that's way out of whack. Excuse me. 1 minute. It's all good. I don't know. So, you need to know how to use the sine law. And I told you on Friday that we're going to start today off after we review with a quiz. And I'm going to give you two triangles, very similar to what I just put on the board. One of the triangles will have a missing side that you have to find. You're going to need a separate sheet of paper to do your work on. I want to see your work. So what does it mean when I say I want to see your work? I want to see, for example, if I gave you this question, I want to see this, and there's something else here that I would want to see that we didn't do, and that's when we found this angle of 40 degrees, right? When you found that 40 degrees, you had to take 180 minus the 82 and minus the 58. And I didn't write that down, and I probably should have. But I want to see your work, okay? So you're going to get two triangles. I don't think it's going to take many of you very long, but we're not in a rush. Okay, we do want to get started with the cosine law today, so we need to start by taking out a sheet of paper that you can do your quiz on. It's not a handout quiz. I'm just going to put it on the board.
Seriously? You wrong.
No, I got stuff for you.
Okay, good.
No, I'm just not right now though. What's that? You need some paper? I'll set you up with some paper. Give me a second to write down the questions so that we can get started though. All right, I'm going to pull a pin on this. If you're not happy with your quiz mark, and I don't mean to minimize it, a quiz is important, but if you're not happy with the quiz mark when you get it back tomorrow, I'll give you an opportunity to prove to me that you can do the material by writing a second little quiz sometimes, maybe Wednesday at lunch, something like that. It'll only take you about 10 minutes. So I need everybody to pull focus back up here, please. John, thank you. You need a calculator. You need something to write with. You need to pay attention, please. Don't try to get too far ahead of me here. This isn't a really heavy task that we have left today, but I don't want to lose anybody. I think you're doing really well in this unit so far. We're going to be looking at the cosine law. You were just given this handout. And just like there is a law called the sine law, and we use it for a certain situation, there is a cosine law. Let me give you a couple of illustrations of triangles. So there's a triangle. Here's another triangle. And I'm going to label some information on these triangles. The first triangle, I'm going to say that this is 12 centimeters. This is 14 centimeters. And that's 28 degrees. The second triangle, I'm going to label some information as well. Oh, we'll go inches this time, doesn't really matter. 19 inches. And 11 inches. If I told you that I wanted you to make this triangle in the left that's in green, that has the numbers in green, and I gave you pieces of sticks or wood or meter sticks, whatever, you could cut a length of wood 12 centimeters long and a length of wood 14 centimeters long, and you could put them at an angle of 28 degrees apart, and then you would know exactly how long this side is. There's only one way to do it. If you could build this triangle, and Chase built it, and John built it, and Delaney built it, they'd all have the same length for that missing side. There's only one way to do it. On the other hand, if I gave you 3 pieces of wood, one was 19 inches long, one was 28 inches long, one was 11 inches long, and I asked you to make a triangle, there's only one way to do it. You fit the pieces together. And that means that all of these angles, if you built it, Ryan, and we measured that angle, and if Dakota built it and we measured that angle, and if Jaden built it and we measured that angle, we'd all have the same angle. So there has to be a way for us to determine the missing sides and missing angles in these. But what do you notice about these triangles and the information we have? And I know I'm being a little cryptic. I don't want to give you the answer. Take a look at them. What's different now compared to what we were just doing 25 minutes ago? Casey? There's no pair. We don't know a side angle pair. Sine law is useless to us. And whenever you have either of these situations, we actually call this something, side, angle, side. It means you know a side, and you know the angle, and then you know the next side. Look at this triangle and notice that this angle is between these two sides, isn't it? Well, this angle is between the two sides. So if we ever see side, angle, side, we're not going to use the sine law. Whenever we see side, 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 we can't use the sine law. What we use instead is the cosine law. Now, by the way, I mentioned this earlier on in the unit. There's no tangent law. There's a sine law and a cosine law. That's all we need. The cosine law, and this is in your handout, but I've got it up here. It's a little clearer. In any triangle, just like with the sine law, and I hope you'll notice all of a sudden things have gotten more confusing, yeah? It's not just A over sine A equals B over sine B equals C over sine C. It's difficult. It's complicated. Let's forget about this bottom formula right now. Let's not worry about that. What this formula is used for is to find a missing side. Now, if we look at, I want you to focus up here, please. I don't want you working on any problems right now. Okay, please. If you take a look at how this formula is arranged, it is rearranged with a side squared on one side of the equation. And this is the side we're trying to find with this formula. Notice that the angle in the cosine law pairs up with the side we're trying to find. This is not simple. There is a pair here, but we don't know both of them. You use the cosine law to find a side when you know the angle across from it and the other two sides. If we were to take a look now, and I'm just going to make an example up, we won't worry about your handout, at me trying to find this side, if that was 12, and this is 11, and this angle is 36 degrees. Take a look at the cosine law on your formula sheet, or on your handout. It's right, may I borrow this? It's right here on your handout. It's a little more than half of the way down. It says a squared equals, and what are the next letters? Then it says b squared plus c squared, right?
Yeah.
Look at the board here. Do you see a b or a c anywhere? No. But if this is a, b and c have to be the other two sides. You with us? Good. So that means we're going to write 11 squared plus 12 squared, and then look at the formula. Look about halfway down your page. It says minus 2bc cos a. I'm looking at this formula. B squared plus c squared minus 2bc cos a. So I have to write minus 2 times 11 times 12 times the cosine of 36 degrees. And you're going to get lots of practice on your own, but I just want to show this to you a couple of times first. Now listen very carefully. I want to really try to make this as simple as possible. Would you agree that 11 squared is just some number? I don't care what it is. Would you agree 12 squared is a number? Would you agree that cosine of 36 is a number? And that must mean 2 times 11 times 12 times cosine of 36 is a number. All I am getting at is that this thing is just a number. I mean, that doesn't mean we're done and we can go home. We have to be able to calculate the number. And this is what I want us to focus on for at least the next 5 minutes. I want to make sure everybody knows how to find that number on your calculator. And you are not, take my advice here, you are not going to do this in pieces. Don't go 11 squared equals and then plus 12 squared equals. I want to find out, first of all, how many of you, and you're going to need to enter this on your calculator, how many of you can enter this entire thing on your calculator and hit equals and get the right answer, okay? If you have a graphing calculator like the one I have up here, there shouldn't be an issue. But we've done lots of stuff in this class where we have different calculators and people have to learn how to use those calculators properly. So I'm going to enter this. It's 11 squared plus 12 squared minus 2 times 11 times 12 times cos of 36 degrees. That's how you enter it. Don't overcomplicate things here. You enter it exactly as it appears. And I want everybody to try that on their calculator because I want to find out if your calculators are going to give the right answer. When I hit equals on mine, I get that number, okay? So if it's 5 minutes, it's 5 minutes. If it's 2 minutes, it's 2 minutes. But I have to walk around the room and make sure everybody is getting that number. And as I said, I think if you have a graphing calculator, no issue. Ryan, did you get it?
Yeah, I got
Okay,
it.
good. Oh, this will be easy then. Everybody's getting it. John? I want to see you get it, please. Okay. What- Okay, you good? Good. You got it, you said. You're fine. You got it?
Yeah.
Okay. Casey, no problem, right? And you're good. Riley? Okay. Good.
Is that the what one?
What's he looking for?
It's right here, Josh.
Okay, just one more minute. I just have a couple more people I want to check on. Be patient. So I'm getting 51.4195, and I think you all have it. Okay, good. Now, as is sometimes the case, we're not necessarily done. It's like on the quiz that you just wrote, the second question, you may have thought you were done, but you might have forgotten to go inverse sine to get the angle, right? Here we are not done. This looks like a legitimate answer. It's the length of a side, but this is a squared. This is not a. We have to take the square root. And we've encountered that earlier in the course. So a will be equal to the square root of 51.4195. And I think on a non-graphing calculator, you just probably hit the square root key and it does it, or you might have to hit the square root and go equals. On mine, I have to go square root of the answer, and I get about 7.2. Okay. All right, so A is 7.2. We're going to do one more example together that I'm just going to make up. And then we're going to do an example together that's in the handout, and then we're going to get some practice. So here's the next example. Remember that I don't attempt to, I try to draw these things relatively reasonably to scale, but they may not be perfect. What is B? Well, we have a problem here. And the problem is that the cosine law is rearranged for the wrong letter, isn't it? I'm telling you that on the very first sheet of your handout here, when it says a squared equals b squared plus c squared minus 2bc cos a, that's what you're going to be given on an exam. Are we going to rearrange this for b? No. Listen, and really think carefully. This cosine law simply says the side squared that you're trying to find is the others squared minus the product of 2 times the others times the cosine of the angle between the sides. It doesn't have to be b. It could be any letter you want. We just go b squared equals, and listen, if you want to, and you don't have to write this down, okay? But if you want to, this would be the cosine law to find side B. All that is important here, everybody, is this side that you're trying to find matches this angle that you know, and everything else are the other two numbers. So when we write this out, and as I said, I don't think you need to write out this statement. You could simply say, well, okay, I know two sides and the angle between them. to find the missing side, I do this. 42 squared plus 28 squared minus 2 times 42 times 28 times cosine of 20 degrees. You know what? It's almost like a rhythm kind of thing. It's a pattern. Side squared equals side squared plus side squared minus 2 times side times cosine of the angle. And once you get used to setting that up, remember what I've told you, this is just a number. It's some number that b squared will be equal to. So you figure out what that number is. Are you okay, Carter? You okay? You figure out what that number is, and then you take the square root. It's that simple. So I would like everybody to get an answer here. I don't want you to just stop at getting that number. I want to know what the value of b is. And again, you can overcomplicate this. It's just a matter of figuring out what that number is so you can take the square root. I'll give you a minute to do so. I sent down just a single handout, the class set that I'm going to need. They don't need it right away, but they will. Yeah.
I'll walk slowly.
Okay. LJ, what'd you get? 18.38. Riley? Do you? Can you share with me what that was?
That's what I got.
Square root.
Oh, okay.
You got to remember to take the square root at the end. So if you got, what was that number? 380? 337. If you got 337, you didn't do anything wrong. You're just not done. You got to take the square root. So when I do it on my calculator, and I'll show you the numbers so that you can check your work, what would I do? I would go 42 squared plus 28 squared minus 2 times 42 times 28 cosine 20. You don't need to put a multiplication sign between the 28 and the cosine. You can if you want. So you get this number, which you thought you did wrong. You didn't do anything wrong. You just now have to get out of here, take the square root, 18.4. Now, what I would like everybody to do, and I don't want you to do this just on your calculator. I'm going to give you a minute here to do example 1 on your own. It's on the next page of your handout. I want to see a statement that says a squared equals, and I want to see all the numbers that you're putting into your calculator. Then you can calculate the answer. When I'm satisfied that you've got that answer done correctly, you're going to be working on some build your skills problems, and Mrs. Gillow will be back shortly with a little handout that has about 8 triangles on it where you have to find a missing side using the cosine law. So I want to see your work here as well as an answer. I'll give you a minute to do so. That's right here. And what I would say, I was just going to say this to somebody else because I saw the same number. You know, take a look at the diagram. The diagrams are not always drawn perfectly to scale, but, you know, ask yourself if the answer you got kind of makes sense with what you're looking at. So, for example, if you got 26 as a value for A, I think you've done something wrong or you're not finished. So I'm going to start making my way around the room, giving you the thumbs up to move on. You have 2 tasks to complete. Build your skills 1 to 3, and this starts on page 276 of the handout. And then I have an additional single-page handout, and I have to wait for Mrs. Gillow to get back with it so that I know which letters I would like you to do as well. And I'm probably going to be taking in that single-page handout as your assignment for the cosine law. Well, your first assignment for the cosine law. Okay. So I'm going to walk around the room. Can you just show me the number you got for side A on example 1? Perfect, you're good to go. Yeah. Pardon me?
Do you always have to put the 2 there?
Yes. You know what, though? I'll mention that to everybody. It is so easy to make a mistake. Here's the cosine law. I taught a whole lesson in Math 20-1 once where I forgot the 2 every single time. Felt like a fool. Don't forget the 2. That's what was just asked is, do you always have to put that 2 there? And that 2 has to go there. Yeah. Yeah, quickly. Did you get 5.4?
Yeah.
Okay.
Oh, sorry.
Yep, that's right. That's right. You get 5.4? Here. No, sorry, here. Yep, okay, you're good. What'd you get?
I'm still working on
Okay, let me know when you're done. Okay,
What I got.
yeah, yeah.
What did I work on after this? Or is she bringing that paper?
The first thing you're working on, and you won't get the handout just yet, but the first thing you're working on is the handout that I gave you today. You're doing build your skills, numbers 1, 2, and 3 it starts on page 276. So immediately after this example that you just finished, there's build your skills. The handout is going to be, it's actually going to be questions 1 through 6, and this is to be turned in. And I want to see the amount of work that I just asked you to do for example 1. You know, quite frankly, I don't care what you do in the build your skills, but when I mark this that's going to be turned in, I want to see that work. Okay? And you're not going to get that just yet. I want you working on the build your skills first. And in about 5 minutes, I'll give it to you.
Does it matter if you put like C or B or B or C first?
No. That's another good question, everybody. If you just look up here for a second. When I wrote this out, what's being asked right now is, do I have to go 42 squared plus 28 squared, or could I switch them? And you can switch them. And you could switch them here and leave them alone here, or you can switch them in both places. It doesn't matter which of the other sides go first or second. So I'm going to give you guys about a five-minute start here to get into your cosine law groove here with those build your skills questions, and then I will hand out that assignment.